sampling. A stratified sampling is a random sampling which maintains a predefined percentage of positive class 1 cases in both the training and the validation set. So this helps us build models which are more tuned, and we do this in the case of the data set having very few class 1 outcomes. So we'll work with the Optavia data set. We'll open the Optavia large raw, and when we import this file, if we look at the distribution of our loan default, which is our category of interest, we go to Analyze, click on Distribution, and let's move loan default here. Well, let me actually make one more change right off the bat. This is a categorical variable. We will call this as a character and as nominal, because that's what our model will eventually be treating it as. So we go to Analyze, click on Distribution, and I move this here. We see that there is just a very, very small percentage of data that is actually 1. In our entire sample of 43,193 customers, only 782 defaulted, which in percentage terms is only like less than 2%. If we were to do a random sampling here, we are very likely to miss out on these either in the training set or in the validation set. So in either case, our model will not be able to be tested against, or either we will not fit a good model, or a model will not be able to get tested against validation or test data sets if they do not have any of these. So this is the severe imbalance calls for a stratified sampling. We cannot just do a normal, regular random sampling. And we'll also, in this case, actually create 3 partitions. We will have training, validation, and testing. So I will work with 2 different ways, the default settings of the add-in plus what we discussed before, in which we can have a predefined setting. So to create a random partition, stratified, we will go to the add-ins, we will go to the random set seed, and let's set the seed as 9876. It could be anything. As long as we keep that number the same, we can replicate analysis at a later date. And now, using that initial seed, we'll go to add-ins, click on stratified split balanced, and if this variable is not highlighted, make sure that this is highlighted, because this is our variable of interest, and JMP will actually look at that while creating the training and validation sets. Now, the first option, the default option, is the option which is this truly a random sample. So in this, we have 60% of our observations as going to training set, 20% as validation, 20% as test. So I could also change it to, if I wanted 75, I could write this as 0.75, and then I could call this at 0.25, and then we'll have to say that as 0. So then this would be like a purely random sample where it pulls out 75% of the observations into training set and 25% of the observations into validation set. And we see that there are problems in our case when we have only less than 2% of cases as success or default. So we will go back to our 60, 40, 20, 60, 20, 20 partition. And because we want to do a stratified random sample, we will say alter the proportion in training. Then we need to specify which of the groups we want. We'll say our focal group is class 1. So now if we run this, JMP produces a couple of charts. In the first chart, it shows that 60% of the data set has gone to training, 20% has gone into validation, and 20% has gone into test for class 0, and the same for class 1. We had a total of 782 cases of class 1. Out of these, 60% have gone to the training set, and then 20% have gone to the validation, and 20% to test. And this indeed is borne out by this result. So what this data set shows is that of the 940, like of the total cases, the test set has 50% of cases belonging to class 1, then 50% of cases belonging to class 2. And then it has maintained the other sample. Remember in the data set we had 1.8% of class 1. So it has kept the balance the same in training and validation. So what is interesting is if we add these things up that we will be using for stratified sampling, we're not using the entire 42,000 observations. We are using a selection of those. Now that's one way of doing this, but because we have such a small existence of class 1 observations, I want my training set to be less greedy. So what I mean by that is instead of doing a 60-20-20 split, I might actually favor a slightly different. Now when we want to recreate a different partition, we will have to reopen the data set again. So I'm going to go back to Optavia Raw. We click on Import. We'll have to undertake the same steps. We will have to first set the seed, analyze, go to add-ins, then random reset. Let's again call it 9876. We click OK. Of course, we had to change this to categorical, so I should do that first. We make it into a character variable, then we have nominal, we click OK. And now let's reset our seed, because every time we are doing stratification, the seed needs to reset 9876. Click OK, then go to add-ins, and then now our stratified balance split. Now this time I might be less greedy with my training set, so we could say that the training set should have maybe 25%. That's the other convention. In highly imbalanced samples, we may stick with 25, 45, and 30. And the remaining number is 30%. We will want to balance the proportions in training. We select as a focal group category 1. Again, we'll leave all the other options as defaults. We click OK. So now this is the new partition that we get, where 25% of our yes values to default have gone to the training set. 45% have gone to the validation set, and 35% or 30% have gone to the test set. Now notice this is something really neat, and that's what we mean by stratified proportion. We said that in our training set we need to have 50% of the observations as the positive class, and that's what we have. So the training set has only 390 observations. And then in the validation and test, JMP maintains the same ratio of the successes, less than 2%. So this was our actual success rate in our entire data set, and JMP has maintained that for validation and testing. So this is really neat. In a stratified sample, we can build a model on an overabundance of class 1 observations than what the data set exists. Once we have built a model, the reason to have a good validation and testing set becomes all the more important, because now we will be fine-tuning our model on the validation test based on the actual proportion of class 1. And then once we have done that, we will check how good our model does based on the test set, which also maintains the actual success ratio from the data set.